Welcome back, Earth Science students. We are going to continue our work with climate today, and we are also going to be looking at specifically how thunderstorms form. At the end of this, I have a little project for you to do based on different types of storms and different kinds of weather that you guys are going to do a little bit of research about, kind of like how you guys did for mass movements. And we're going to do something similar where you're just going to make a PowerPoint presentation, super easy. You'll look some things up, pretty straightforward. The reason we're doing this again is we're in our climate unit. I left off last time talking about air currents and how they affect weather and low pressure systems, high pressure systems, and that sort of thing. So we're going to get into weather, and so let's talk about how thunderstorms form. So you'll see me refer back to these three things for thunderstorms multiple times throughout this video. That's because they all pose their very important to have all three in order to create a thunderstorm. So number one, you need to have some source of moisture, whether that be from lakes or from the ocean, okay, but some source of moisture in the air. Next, you're going to have a lifting of the air mass. If you remember, low pressure systems are when air is moving up. Okay, high pressure systems move down. That's when we have our warm weather and our nice weather. When the lifting of air mass occurs, that is when we tend to get worse weather. And number three, we need an unstable atmosphere. Basically, what we need is some kind of disturbance in the atmosphere to allow for these things to happen, accompanied by either wind or other things, and we'll talk about them to create these thunderstorms. All right, so first of all, we need some definitions. Air mass, a large volume of air that has the same characteristics like temperature, humidity as its source region. So this air mass is like the air that sits over northeastern Colorado. Okay, so that's a giant air mass, a large volume of air that has the same characteristics as the region it sits over. Source region is the area over which the air mass forms. Most form over polar regions or tropical regions. Okay, all of these things form, and as they move around, they either gain temperature, lose temperature, with our whole convection-like properties where warm air rises and cold air sinks and that sort of thing, all go to why these air masses move across our Earth. Next, we have cumulonimbus clouds, tall clouds that grow due to unstable conditions in the cloud. Basically, it just keeps accumulating all this moisture, keeps accumulating all of this condensation, and eventually leads to the precipitation that falls in a thunderstorm. Okay, so here we have some types of clouds. What we're going to care about for thunderstorms in particular are cumulonimbus clouds, formed from the cloud being warmer than the surrounding air. This tends to cause these things to gain a lot of moisture, which is going to fall down as rain. Okay, so steps. Cold air condenses the water. Okay, it releases latent heat. Okay, so it's going to release a bunch of heat. Okay, it grows taller, or grows the cloud taller and taller. High winds skew the shape of the cloud into an anvil shape. So if you see these really tall clouds, those are all due to the winds pushing them in certain ways. And lastly, the cold temperature at the tropopause allows water to freeze and form hail. That's why during thunderstorms, we tend to have so much hail rather than just rain. Okay, so if you imagine as you go up into the atmosphere, the temperature tends to go down the closer you are to space. So at the tropopause, it gets so cold that the condensation inside the cloud actually forms into those little ice balls, and it falls all the way from there to the Earth. All right, so here's just a graphic about average thunderstorms, thunderstorm days per year. You'll notice that where we are, is actually this orange little patch in Colorado where we actually tend to get more than most of the places around us. Now, we live in a very special place because we're right on the other side of the mountains. And so we'll talk a little bit about how the mountains help us, help in the making of thunderstorms and why we get so many. You'll notice, though, for the most part, that most of the thunderstorm days are actually in the south. Coming off the Gulf of Mexico, there is a lot of moisture, as well as if you follow the Mississippi River, there's a lot of moisture in the Mississippi River and those sorts of things, and that's why we tend to get more days that we have thunderstorms along those bodies of water. Okay, so like I said, number one, we need a source of moisture. Number two, we need lifting of the air mass. And number three, an unstable atmosphere. Okay, so we're growing our cumulonimbus cloud here. Hopefully you can see that. And eventually it becomes big enough that it is going to start precipitating. Okay, so sources of moisture, let's talk about those first. Evaporating water from lakes or oceans is what causes this source of moisture. Humid, less dense than dry air rises. Okay, so it eventually goes up into the air where it can condense. As you guys know, you guys covered the water cycle in depth in middle school. I think just last year you guys talked about it. It condenses as the atmosphere becomes colder, and then it falls down as precipitation. Okay, lifting. The warm air must meet cold air in order for it to be lifted into higher altitudes. For us, the Rocky Mountains really help with that because obviously the air has to go over them. It's going to lift that warm air and that cold air up in order to cause that to happen. Okay, and then as far as the instability of the atmosphere needs to keep cold/warm difference to maintain a thunderstorm. This is why thunderstorms fade at night, mostly because of this imbalance of cold versus warm air that's coming into the atmosphere. If you look at my diagram, it shows it more in depth about how we still have warm air rising and cold air sinking and that sort of thing, and how that perpetuates the thunderstorm. And then as it goes into night, you have mostly just cold air. Okay, so you don't have that mixture and that difference to maintain the thunderstorm. Okay, the thunderstorms, the source of moisture creates the clouds. Lifts create the height. Okay, the cumulonimbus clouds that grow really, really tall. The lift helps do that and helps that water that's condensing access colder temperatures to either come down as rain or come down as hail. The instability of the temperatures between the cloud and the air perpetuate the storm and let it build on itself. And then just like we talked about last time, our global winds are what carry that weather across the earth. So for us, the prevailing westerlies carry that across the mountains, across us, and into the eastern plains. Okay, I want you guys to watch this cool video on lightning. Obviously, we know that during thunderstorms, there's a lot of lightning, and this video goes into explaining how it occurs and why it occurs. It has to do with, again, static electricity and how the formation of thunderstorms allows that stuff to happen so that we can get lightning. Now, your severe weather research project is going to go this way. So you can pick your own as long as we have a relatively even distribution of choices. Usually I do that in class, but for this, I really just want you to pick one that you like, that you think might be interesting. I have a feeling there's going to be a lot more of the supercells and tornadoes and cyclones and hurricanes, which is fine. Those tend to be the cooler ones, if you will. But either way, if you're interested about any of these, they're all kind of interesting in their own ways. Ice storms, if you've ever been in one, are pretty crazy. You're going to be doing this on your own. And things that I'm going to need in your PowerPoint presentation. Okay, how that storm forms, where it forms, specific examples from history, and how it affects humans locally, nationally, and globally. Now, I want you to think deeply about that last part, because I don't want you to just be like, okay, well, flooding, well, locally it causes damage. Okay, I want you to think more deeply, like over the course of time, what else could flooding cause? Okay, nationally, globally, anything along those lines. So think about even like the flooding in Houston. Okay, it didn't just affect the people in Houston; it affected the surrounding places. I mean, it affected us even. Okay, just think about those things more critically than just simply, oh, well, it rained there. Okay? Here's an here's an example I did with a volcano. So for example, locally, obviously there's going to be lava flow near the volcano. Later though, if it was triggered by an earthquake, it can cause tsunami. Ash falls weeks later in places all over the world. It can affect the climates and make weather and seasons more drastic in years to come, and all kinds of things. The the image here, if you imagine if there's enough ash in the atmosphere, it's going to repel the sunlight, causing our winters to actually be worse. Even though we think, volcanoes give off a lot of heat, so you would think that maybe it would make it warmer. Not exactly the case, because of the ash it puts into the atmosphere that actually reflects the sun's energies. But think about things like that. And if you have trouble thinking of those things, make sure that you reach out to me. We can have a discussion about it. And to be honest, that's all I have for you guys. If you have any questions, all I have for you for this video is a check to do. 5 questions, easy. Make sure that you're trying to get a 5 out of 5. They're directly from this video and then this project. Now, that means that next week we will be finishing up our unit and taking our unit test. Okay, and then we will also be beginning our final unit of the year. I don't know if you guys know what the last day of school is, but it is quickly approaching. We are about a month out, less than a month out actually, I think. So make sure that you're staying on top of your stuff. And as always, thanks for watching.